share an innovative digital tool I've created for teaching 3D shapes to primary school students. Let me just share my screen. So what you're looking at is a 3D Shape Explorer quiz, a digital learning tool I built by using Google Forms that has transformed how you can teach geometry in the classroom. Now, I know what you might be thinking. Google Forms, isn't that just for surveys and tests? That's exactly what makes this approach so powerful. I've reimagined this simple, free platform into an interactive learning experience that guides students through 3D geometry concepts in a structured, engaging way. In the next 10 minutes, I'll walk you through how I would use this tool in my classroom to demonstrate how it addresses 5 essential aspects of effective teaching: facilitating deep learning, promoting engagement, ensuring accessibility, making learning enjoyable, and developing critical thinking skills. So let's start with the basics. The 3D Shape Explorer quiz is built entirely in Google Forms, which means it's completely free and accessible on any device with internet access. I simply searched for Google Forms and created a new form. What makes this more than just a quiz is a thoughtful structure. I've organized it into progressive sections that build conceptual understanding step by step. See, we have level 1, starts with shape identification. We have level 2, which is shapes in our world. Then we have level 3, which is advanced geometry challenges. It begins with simple shape identification. So as you can see, it begins with simple shape identification and moves on to analyzing properties like bases and vertices, which then culminates into higher order thinking tasks, which is where the advanced geometry challenges come in. Let me show you how I set it up as a quiz. So what you're able to do is you're able to go to settings, under settings, turn on make this a quiz, and set it to show correct answers after submission. This immediate feedback is crucial for student learning. As you can see, I've added colorful images of 3D shapes throughout using both geometric models as well as real-world objects, such as this Coke can here. The quiz includes multiple question types, such as multiple choice, matching, short answers, and long answers. The first way this tool enhances learning is through its progressive structure. So instead of treating 3D shapes as isolated facts to memorize, I've designed a sequence that builds understanding through 3 levels. As I previously mentioned, at level 1, students can simply identify basic shapes like cubes, cylinders, and pyramids from different angles. At level 2, this digs deeper into properties, so students count faces, edges, vertices, and this helps them develop an understanding of what makes each shape unique. Then by level 3, students are making connections and finding patterns. For example, this question is an imaginative question. So if a classmate says a traffic cone is a triangular prism, and you ask the learner what's wrong with the statement, the answer would be it has a circular base, not a triangular base. You can see because we're in edit mode, this is the correct answer. I'll do a demonstration later in the presentation. So this structure supports deep learning because it moves from the concrete to the abstract. So students don't just learn shape names, they understand the mathematical relationships that define 3D objects. We also include multiple visual representations of each concept. So notice here how I showed both the model of a cylinder alongside a cone and a sphere. I also used an image of a can, which helps students connect abstract mathematical concepts to their everyday experience. The second powerful aspect of this tool is how it promotes engagement. Traditional worksheets often lead to passive completion, but this digital quiz keeps students actively involved in several ways. The most powerful engagement feature is immediate feedback. So when a student answers a question, for example, a pyramid's properties, they can instantly learn whether they're correct and why they're correct. So let me demonstrate. So once you have actually done the quiz, let's do a new quiz. And for example, I'll select a cone. What shape is this sphere? Which one of these is not 3D shaped square? So these are just a couple answers. So once you submit, you can view the accuracy. So these are basically the results. Here you can see what is the shape. It's obviously not a cone, it's a cylinder. This is a sphere, and this obviously square is not 3D shape. So this immediate reinforcement is far more effective than waiting days for a teacher to grade and return the papers. You can also see we do get feedback immediately. I started doing this form at 6:17, and you can see we got feedback immediately with the score that the student received, as well as what answers they gave. Most importantly, I've designed interactive elements that require students to actually participate. These engagement strategies transform what could be a dry assessment into an interactive learning experience that keeps students motivated. Making geometry accessible to all learners is crucial, especially in elementary grades, where students have diverse needs. I've intentionally designed this tool with multiple accessibility features. First, you can see there's multiple representation formats, such as multiple choice, as well as long and short questions. Each concept is presented through text descriptions as well as visual images. This ensures students can access the content through their preferred learning channel. Learning geometry should be enjoyable, and this tool incorporates several elements to create a positive, motivating experience. I've added gamification elements that students love, so when they answer correctly, they receive affirmative feedback with encouraging messages. This quiz includes built-in celebrations when students complete the worksheet here at the bottom. So this connects geometry to students' lives through the real-world application questions. Here, for example, we can use the same example. Here, students are identifying everyday objects that represent specific 3D shapes. This relevance helps students see geometry as meaningful rather than abstract. Perhaps the most valuable aspect of this tool is how it promotes critical thinking skills. So rather than focusing solely on recall, I've designed questions that challenge students to analyze, compare, and evaluate. I've also incorporated prediction questions that move beyond identification to application of knowledge. You can see in the last part, in the export path, you'll see problem-solving scenarios that connect geometry to real-world challenges. By structuring questions to require high-order thinking, students develop mathematical reasoning skills that extend far beyond simple shape recognition. So how would I implement this in my classroom? First, as a pre-assessment at the beginning of the geometry unit to identify student misconceptions as well as their prior knowledge. Secondly, while teaching the topic actively, as this will allow me to work with small groups while others can engage independently. Finally, as a formative assessment tool, this helps me track student understanding through the form's response data via the spreadsheet. So in conclusion, this 3D Shape Explorer quiz demonstrates how thoughtful instructional design can transform a simple free tool like Google Forms into a powerful learning resource. By structuring questions to build conceptual understanding, incorporating visual supports, and providing immediate feedback, we can create mathematical experiences that are engaging, accessible, and effective. If you'd like to try this approach in your classroom, I've included a link in the description to a template you can copy and adapt. Thank you so much for your time and have a wonderful day. Goodbye.